On the second part of this experiment, we will be determining the density of an unknown solid. And the solid that we use will be some kind of little beads or rocks, some little pieces of metal. It's not one solid piece of metal. So the first thing that we do is we put the metal into the flask, and there's a lot of air space in there, but we fill it as full as we can, or as much as we have, and you weigh that. So let's say this is 92.13 grams. Okay. To get the mass of that solid, we're going to subtract from the mass of the flask. In other words, I'm going to take or subtract it. Let's see. This is the mass of the flask and solid. And then I'm going to subtract the mass of the flask that I had on the last page. And I'm going to get my mass of my solid only. And I'll put that. Now, sig fig wise, I should cut this off. And so I'll put 45.01 grams of the solid. Then I'm going to take my flask that has the solid in it, and I'm going to add water. I'm going to fill up the empty space with water, and I'll tap it to make sure there's no bubbles. I'll fill that completely full with water. And then I will want to know, then I'll measure the mass of the whole thing. And let's say it's 105.24 grams. This again is a measurement with solid, water, and flask. So what's the mass of the water that fit in there? We'll take the whole thing. This is flask plus solid plus water. And I want to know the mass of the water, so I'm going to subtract off the mass of the flask and solid, which was 92. And that will give me the mass of the water. Okay, and the reason that I'm doing this is because from the mass of the water, I can get the volume of the water, and then I can figure out what the volume of the solid is. This is a trick to get the volume of the solid by using water displacement. Anyway, so I figured out how much water fit in all of those cracks. And then I'm going to go from that to the volume of the water. So I know the mass of the water. This is, I'm going to use the density of water again. And that is given. So to solve my problem, I'm going to take this. And I want grams down here, milliliters up here. And when I use this density, I need to make sure the 0.9982 stays with the grams. So it goes down here. Okay, so I'm dividing to get those grams to cancel. My calculator said that I went ahead and rounded that. Okay. Next, I'm going to get the volume of the solid. And so here's the trick. I know that the volume of the flask is equal to the volume of the water plus the volume of the solid, because I know that the solid and water together are taking up the volume of the whole thing. Well, I knew the volume of the flask from before, so the volume of the flask was 25.15 milliliters for the flask, and I'm going to subtract out the volume of the water, and that will give me the volume of the solid. Okay, on this one I'm careful to write milliliters of what and grams of what and stuff, because there's so many. Anyway, so to get the density of the solid, now all I have to do is use our equation. Making sure I'm using the mass of the solid and the volume of the solid. Oops, grams. This is what my calculator says. I'm going to round out to 4 sig figs. My density of my solid. Now on this one, I didn't keep all the digits, extra digits, as I moved down, but to give you an idea, it would have been this if I had kept more digits as I came down. So I'm really not going to worry about that too much. But just know that this last digit is estimated anyway, so I'm not going to worry about that too much. Anyway, that's our density of our solid.